to chapter 2.1 on quadratic equations. So a quick review from the last notes. We're going to find the quadratic equation with the given roots. And then today we're going to cover more about the discriminant. Okay. So first, let's find the quadratic equation. Hopefully you remember that the c value of the quadratic is the product of the two roots. So I'm going to take my first root, which is 2 minus root 5, and multiply it by my second root, which is 2 plus root 5. I'm going to show my FOIL skills here. You'll get 4 plus 2 root 5 minus 2 root 5, and this actually will become a negative 5 when you multiply negative root 5 times root 5. Like before, these little things will cancel. They're the same. So I am left with a negative 1. So my c value in my quadratic equation will be negative 1. Also, the negative b value is the sum. So I like to put the negative sign out front. And now I'm going to add my two roots. 2 minus root 5. Add it to my next root, which is 2 plus root 5. Notice I have no denominator, so I can just combine like terms. These are the same, they will cancel, and I'm actually left with negative on the outside, 4. So my b value, negative b value, would be negative 4. Okay. Again, this pattern is super nice when I have a quadratic, because then I have my values and we can just plug in. I know my a value needs to be 1 in order to even use these tricks. My b value, plug it in. C value, plug it in. And have it equal 0. Okay, if you're still having questions on that, please make sure you ask during class. Now moving on to the discriminant. So the discriminant is consider the quadratic equation given where a, b, and c are real numbers and a is not 0. The expression b squared minus 4ac is called the discriminant. In other words, the discriminant is what is under the square root. Okay, that b squared minus 4ac is the portion under the square root in the quadratic formula. So there's 3 cases we can look at. First one, if the discriminant is greater than 0, then you're going to have 2 distinct roots. That means you'll have 2 answers, probably an answer that's plus the square root and an answer that's a minus square root. You also could have the discriminant equal 0. That means you have 1 real root. We did an example like this on the last day's notes. When you get the square root of 0, you'll only end up with 1 answer, because when you add or subtract 0, it will be the same answer. We also briefly talked about what if under the square root is negative, less than 0. Then it will have no roots. But now we're going to go in detail and talk about what those roots actually are. Those are when you have a square root of a negative. You're going to have a complex conjugate roots. Okay, we'll talk all about that today. So, quick example for you based on the discriminant. So, part 8, compute the discriminant to determine how many real solutions there are for the equation. X squared plus x minus 1 equals 0. Notice you do not need to actually perform the entire quadratic equation. You can simply plug in to the discriminant, and based on your answer, you can tell how many roots. By all means, you can do the whole quadratic formula, solve for the actual answer, but we like the shortcuts, right? So when I solve, I find out that my answer is 5. Under the square root is 5. That falls in the first situation of my discriminant on the top. it is greater than 0. So that means I'll have two distinct real solutions. Okay, you don't even have to tell me what they are. I'm just asking how many solutions there are. Now, the next one says, find a value for k such that this quadratic equation has exactly one real solution. Now we're going the other way. If I have exactly one real solution, I need to be in this second case right here. Right? One real solution, one real root, has to have a discriminant equal to 0. So you have to understand those rules. So what I'm going to do for part B, I'm told I need one real root, or one real solution. So I'm telling myself the discriminant has to equal 0. Well, looking at the equation, I know that b squared minus 4ac is going to have to equal 0. That's what I mean by the discriminant has to equal 0. Well, let's plug in my values. There's my a, my b, and then my c. Notice it equals 0, so I can take those a, b, and c's just as they are. So b is root 2, a is a 1, and it's kind of weird, but the value c is k. And I'm going to actually put the k in here because the problem asked me to find the value for k. So you need to have k in your equation. So I'm going to solve this for k. And I get k to equal 1/2. Okay. Now a way to check that is actually plug that value in to your original equation, find the discriminant, and it should equal 0. This will give me my one real solution. Okay. Last example for you here is we're going to use the quadratic formula to solve this. Okay. So plug in like normal. When you simplify, I'm getting -7. Okay, we talked about this in notes last time. When you have that negative under the square root, it's imaginary. So looking back at the chart above, there it is. If under the square root is negative, you're not going to have a real root, but you're going to have what's called a pair of conjugate roots. Let me show you how we're going to simplify this. When you do so, you have your -1, your plus or minus, your over 2. I would like you to take out the value that's positive, so in this case it's root 7, and then in the other square root you'll have square root of -1. These are equivalent. Okay, you should know that with your radical work. It's equivalent. When you multiply under a square root, you can get, you just multiply the values under the square root. The reason why I do that is because, again, nothing else changes over here. That root 7 will stay, but -1 under a square root actually simplifies to the letter I for imaginary. So you're going to get I times root 7. Please make sure you put that imaginary in front. You never would say root 7I, more because the I might fall under your square root if you do that. So know that this right here just this portion, -1 under a square root simplifies to I, and this is how you would write it. So this is how we solve the problem. Simplify that negative under the square root. Sorry, I don't like that. Okay. This is what's called that complex conjugate. And it's only happened because the discriminant was less than 0. Okay, so we talked about this before. Now we're kind of going in detail simplifying. Please take your time on tonight's homework. You can, by all means, solve these fully and find the actual roots, but all we're asking is for you to tell me how many roots, and if it is a complex conjugate, make sure you solve with your I value. Good luck.